sure Autodesk has a lot of products that have affected a lot of people. I'm gonna let it die down a bit. So as engineers, many of us in here have used CAD software or other resources to create and communicate our own ideas. Some of you have even have used some of Autodesk's products as well, but did you know that Autodesk is a real cool company? They have a position called Explorer in Residence, as I mentioned. This person is Jonathan Knowles. He'll be speaking next. Jonathan Knowles brings together art and science and connects people and ideas to research the intersection of technology and global trends. He is what some of us might call a futurist or innovator. In his past, Jonathan worked for Adobe and Apple, and currently serves on the advisory boards of several space and ocean-related organizations. Today, he's here to describe the shape of things to come. Thank you very much. Let's welcome Jonathan.
Thank you, Cameron. Hi, it's great to be here. I know you think you know Autodesk. Most of you really don't know Autodesk. Talk to Jason Dunn from Made in Space and a few other people here. They'll tell you. Did you know we make tools for designing living things? Probably not. Yeah, we boot our own virus. Cells are hardware, DNA is software, engineers, it's all the same. We're not going to talk about that today, but you probably don't know a lot of the stuff we're doing, right? We've been doing AutoCAD, our first product, for 34 years, but we make 170 different products today that are used in all kinds of different ways. And today, I'm going to talk a little bit about some of the things that we are doing that I think have tremendous applicability to the space world. So first of all, I'm real proud of this, right? Seattle. For those of you who are tweeting, that is my Twitter handle, and of course we're encouraged to use the hashtag NewSpace16. As Cameron said, I am Autodesk's Explorer in Residence, and what that means is besides doing all our space stuff, I do our oceans stuff. So I lead a dive team at Autodesk. I'm the diving safety officer for the company. We have a boat, and we're doing work in the oceans as well. We're doing things like coral reef research to help better understand what's going on with regards to our coral reefs around the world. We are doing things like working with Woods Hole Oceanographic Institution to do underwater archaeology. I know, big software company doing underwater archaeology, but this is from the wreck of the Antikythera, news just today. As a matter of fact, about new discoveries on this ancient wreck from 65 BC. I get to do paleoanthropology as well as archaeology as Autodesk's Explorer in Residence, and we're applying these digital tools, reality capture technologies, to better understanding our world's past as well as humanity's past. So we work with people like Louise Leakey. You should check out africanfossils.org, as well as the people at the University of Witwatersrand in South Africa. It means I get to work with people like Bruce Pittman. Where are you, Bruce? Here somewhere, at the new NASA Frontier Development Lab, which will kick off next week at NASA Ames. It's very exciting, working on some asteroid stuff. You should check out NASA Frontier Development Lab. It means I get to work with companies like, be an advisor to companies like Made in Space. You'll hear from Jason Dunn here at the conference, the CTO and co-founder. These are the folks who put the first 3D printer on the space station and just recently put the second one. Of course, we don't call it a 3D printer, we call it the additive manufacturing facility, because it's NASA and the space station. Before we get started, I need to take you back in time. By the way, who knows what this is? All the old people, right? What? You know, I'm telling you, you look up time machine and do a Google image search, this is not what comes up, but this is what I wanted. This is the time machine from H.G. Wells. This is what you get when you do a Google search for time machine. Who knows what this is? Yeah, see what I mean? Yeah, okay. So let's go back in time. You see, over the past, I'm going to talk about tools, by the way, because that's what we do at Autodesk. We make tools, and I want to tell you a little bit about tools. So let's go back in time, because over the past 3.5 million years, we humans, we have created our tools, and thereby created our world. And at the same time, those tools and the things that we've created with them, they have also shaped us. So this is the very first tool shaped by human hands, this stone axe, we all recognize that. And this is the human hand that was shaped by that stone hand axe. You see, we've always had this intimate interplay between our tools and ourselves. And yes, we created a tool like this, the spear, but it also created in us a developing brain that gave us better eye-hand coordination. And also the ability to think strategically, enough to organize a hunting party, for example. And we've also co-evolved with our tools. They've shaped our bodies and our thoughts and our behaviors. We started with simple machines using wheels and levers to stack stones on top of each other, and these tools gave us the power to imagine things like pyramids. When we developed mass-produced steel, as well as rivets and cranes and elevators and, yes, even the drafting table, these tools, they were new at the time, they helped us to reimagine what buildings could be, and that gave us the first skyscrapers. And from there, we made buildings that literally twist to the sky, and spacecraft that took us to new worlds. But there's two sides to every tool. You see, they initially expand our capabilities, but ultimately they constrain our thinking. For example, the same drafting tools that gave us the first skyscrapers and rockets also gave us cars that looked like this. Boxy and boring. But do you remember when all of a sudden all the cars just melted? All of a sudden they started looking like this. And our spacecraft started looking more like the future. Well, this change was triggered by a new tool, software, that could model complex curves, allowing designers to express themselves in a whole new language. And do you remember when this meant communication? Back then, our thoughts and our conversations, they were literally tethered to the wall. But now the same hand that once held that simple stone hand axe now holds this, a passageway to the most powerful tool we've ever created, the digital world. And today, because of profound changes happening now in that digital world, we're at another one of those moments where the new capabilities of tool are going to help us imagine and design and create things we never could before. In this digital world that we've created, working in the realm of bits, we've been unconstrained by the limits of atoms and free of the laws of the physical world. And as we've created in this parallel world, enjoying all of this flexibility and freedom, we've literally built our castles in the sky. Think about the words that we've used to describe those places: cyberspace and upload and the cloud. But for all the activity going on up that's not really the big news. Today, I'm here to tell you that the digital world is about to come crashing down on us from above and make its home in the physical world all around us. There have been some early strikes already, and we're starting to see whenever the digital world touches a particular part of the world, it transforms it in profound ways. Think about how it has distilled and dematerialized the entertainment industry and electrified the hospitality industry and all but vaporized the taxi industry. Anything that becomes easily computable also becomes infinitely mutable. And when digitization strikes the physical world, we'll be moving from building things to compiling things. That's important. Digitization transfers our expectations for the physical world and how we design for it. And this is going to change each of the things in the world, but only once we change our relationship with the tools we use to create them. Just like the stone hand axe, the computer mouse has both expanded but also limited our capabilities and therefore our imaginations. In fact, today, we've always been limited by this need to manually push our wills through our fingertips into our design tools. Until now, if you couldn't draw it, you couldn't fully imagine it. And you certainly couldn't create it in the real world. But we can't allow our creative imaginations to be limited in that way anymore. The fact is, we're going to have to let go of our tools, and the good news is that today we can. Because there's a new tool coming, a technology called Generative Design. And with this approach, we can tell the computer what we want to accomplish instead of drawing what we already know. Say I want to design something like a quadcopter. It has to be light enough to fly around, supporting its own weight while carrying a camera. Generative Design meets me at those goals and uses algorithms to automatically synthesize geometry using just those goals and constraints as input. Once I've given the computer that input, I step back and I let it explore the entire solution space on its own, creating millions of options, all that meet my criteria, including the ones I never would have come up with, all in the time it would have taken me to draw just one. And by the way, there's a reason this drone body looks kind of like a flying squirrel. It's because the algorithms are designed to work in the same way natural evolution does. We recently used this technology on a project with Airbus to imagine the plane of the future. Now, of course, realizing something like this plane, it's going to take a little bit of time. But we've already started using generative design to reimagine and redesign some of its components. One is the partition shown here in pink. And here it is. This is a 3D printed cabin partition that is stronger than the original, and yet it is only half the weight, generatively designed. This lighter bionic panel is going to be flying in the Airbus A320 later this year. Now, what about creating the things we design? Of course, robots aren't anything new. We've had them and been using them for decades as tools to create things. And while their physical capabilities haven't changed dramatically, they're doing new and interesting things for us in ways they never had before. But what's really changed is that lately we've been able to go beyond the repetitive tasks we've traditionally given those robots, and we're finding new ways to communicate and collaborate with them. We're expanding their capabilities by connecting them to things like generative design and additive manufacturing systems. This gives them the power to do things they never could before. For example, we've been working with a team in the Netherlands to generatively design and robotically 3D print the world's first autonomously manufactured bridge. This bridge was designed by an algorithm, and this summer we'll hit print and robots will build it in steel across a canal in Amsterdam all by themselves. Now imagine this capability in space. Robots working autonomously in LEO, in GEO, in cislunar and beyond, additively manufacturing for us. Working with a company I serve on the advisory board of, Made in Space, who's here at the conference, as I said, we will see structures that are generatively designed that simply couldn't exist anywhere else. We'll be able to realize things that can only exist in software and in zero gravity. Think about that, right? They're not under the constraints of what we have to deal with here on Earth when we're designing something and making something. We will have possibilities that are close to, if not endless. Now, of course, this does change what it means to be an engineer, and I know what I'm about to say can be a little tricky, so just bear with me. The term computer, it's been used since the early 17th century, right? We all know that. The first known written reference dates back to 1613. And it was one who computes, a person performing mathematical calculations. And this was before electronic computers. This just might be true for engineers as well. Today, you might say, oh, I'm an engineer, and it might be kind of like people who said, oh, I'm a computer. Now, that doesn't mean we don't have engineers anymore. As a matter of fact, my good friend Jason Dunn and I both believe that it makes being an engineer even cooler, because what we're talking about is letting computers do what they do best and letting people do what they do best. It's a big, big change for us, and an important one. So we've talked about computers thinking and acting in the real world. Well, how are these digital worlds going to perceive the world? Let's talk about IoT for just a minute. You know, the Internet of Things, we hear a lot about it. It really is, at the end of the day, a nervous system for the things we create. Our body's nervous system tells us what's going on around us, but the things we create don't yet have a nervous system, so they have no idea what's going on around them. Catching up here, I have to do 2 clicks here, and I don't want to get confused. There we go. But what if those things we created, what if they did have a nervous system? If the things we created could stay connected to the design process, they could improve upon themselves over time. So to explore a design process with a nervous system, we teamed up with some crazy guys down in Los Angeles. They call themselves the Bandito Brothers. They design the practical effects for stunts you see in movies. They're the guys who did the real-life Hot Wheels that you see here. Interesting and fun guys. But we connected with them, and we started with their love for building amazing vehicles. We helped them install a nervous system into one of those vehicles, taking the vehicle and instrumenting it with dozens and dozens of sensors. Then we put a world-class driver behind the wheel and pushed the limits of that vehicle out in the desert. And using this new nervous system, the vehicle recorded everything that was happening to it during that drive, including all of the forces that it was subject to. Then we took all that real-world data, billions of data points, and plugged it in to the generative design technology I spoke about. And look what it designed. A bespoke chassis for that driver and that environment. It's impossible for a human to achieve designs like this. And yet a human did design it, but only when augmented by generative design, advanced robotics, in combination with that digital nervous system. So these new technologies that they're already shaping our physical world today. Let's turn and look at another tool, a technology that is acting as a kind of accelerant to all of these things, and that's machine learning. More than 60 years ago, a clever programmer taught a machine to beat you at tic-tac-toe. And of course, we all know that over the years, computers got a lot smarter. And by 1997, the smartest of them, Deep Blue, beat Gary Kasparov at chess. But that was still just a display of brute force computation. Things got really interesting in 2011 when, rather than working from predefined recipes, Watson had to use reasoning to overcome his human opponent in Jeopardy. And then just a few weeks ago, not that long ago, AlphaGo beat the best human at Go, a game so complex it has more possible moves than there are atoms in the universe. And in order to win, AlphaGo had to develop a sort of intuition. In fact, at one point, even its programmers didn't understand why it was doing what it was doing. And if we look at the time frame for these milestones I just talked about, we can see that there's something exponential and astonishing happening here. In less than a human lifetime, computers have gone from learning a simple child's game to mastering the game recognized as the pinnacle of strategic thought. Less than one human lifetime. There are two things responsible for this acceleration. First of all, the unprecedented degrees of parallelism through GPUs, multi-core, the cloud. And second, we've taught computers how to teach themselves. Let me give you a real quick, simple example. Think of that classic Atari game, Breakout. Now, how did you learn to play Breakout? Who's played Breakout? Come on. You know, you spent long afternoons trying to develop and hone your strategy, right? Well, let me tell you how a computer recently learned Breakout. Told only to maximize the score and that it could twist this knob, a system called DeepMind learned how to play the game better than any human ever in just one night. How? By playing millions of games in the course of that night. Now, think about how we learn and share what we know, right? What we're all doing right now here at the NewSpace conference. Just because you get good at a skill doesn't mean your buddy does. But once a machine masters something like Breakout or any skill, they've all mastered it forever. That's profound. When computers get better at learning, it's going to accelerate generative design because they'll all be able to notice our reactions to what they propose and incorporate our unspoken preferences into the design process. Remember what I said about it changes what it means to be an engineer. And AI, it's also going to give robots the ability to independently complete their tasks without dependence on us for explicit instructions. And for the Internet of Things, AI is going to use the input from this new digital nervous system to not only perceive, but also react intelligently to the real world. And for the Internet of Things, AI is going to use the input from its new digital nervous system not only to perceive, but also to react intelligently to the physical world. So, that's about computers getting smarter. Now let's talk about them getting more creative. As powerful as computers have become up until now, we've mostly used them to solve left brain style problems, basically the logical stuff. And even in the case of the artist, the writer, or the sculptor who's using creative tools, the inspiration has come only from our side of the screen. But now, computers are poised to transcend that barrier and to make the journey into the realm of human creativity. In a way that goes all the way back to Plato's theory of forms. Most of you engineers know that. You know, Plato said that reality contained two distinctive realms, the realm of the physical, which contains real objects, and the realm of the abstract, which contains the forms or ideal versions of specific objects. You know, we can talk about this chair and that chair, but to Plato, each chair is really just a different version of the ideal chair. And today, computers are actually starting to think this way. They're becoming able to grasp the fundamental essence of a thing. This is a generatively designed chair. And once they understand the essence of something like chair, they can help us design better because we'll have a bridge of shared meaning between designer and computer. The fluency of meaning and ability to grasp the unembodied, to assimilate the unexpressed, and to distill the very essence of a thing, that's what's going to make the computer an even better creative partner. And when I say creative, I mean exactly that, including the creative arts. We saw how one computer essentially went to video game school overnight, so why can't a computer also go to art school overnight? This one did. It studied Rembrandt. You might have seen this project from the Netherlands recently. After studying Rembrandt, it painted one. A whole new that didn't exist before. So, board games, video games, and even paintings. Computers are getting better at human-style capabilities, intuition, generating hunches, and making creative leaps. Another way to put it is to say that computers have always been kind of like Mr. Spock, but now they're becoming a little more like Captain Kirk. You know, Spock is logical and brilliant, but as we saw in countless times on Star Trek, that was almost never enough to save the day. In fact, it was usually Captain Kirk who came up with the ultimate solution for whatever they were facing, and it was usually something that had to be driven by hunch, intuition, and creativity. So today, that's exactly the kind of unbridled imagination we need to address our biggest challenges here on Earth and in space. And fortunately, computers are starting to develop human-style abilities to augment our own abilities. So what's it going to be like when computers can generate fresh insights on their own and make independent creative leaps just like we do? It's going to fundamentally change our role as humans in the creative process. In the past, and for millions of years, humans have taken the role of operator with our tools, telling them exactly what to do and expecting them to do it. Today, our role is more like that of a curator, where the computer generates options and we judge the suitability of those options. In the future, I think we'll be more like mentors to our tools, coaching them, providing them with guidance, providing them with experience. Think about any creative professional or any curious person who seeks out a constant stream of different, often challenging experiences as a way of continually growing, and how teachers do the same for their students in their classrooms. In the same way, we're going to have to do that kind of mentoring for our increasingly intelligent and creative computers. Now, I said earlier that we humans have shaped our world. Moving forward, we will increasingly be shaping the things that shape our world. And what will they then create, is the question. The world around us has, to some degree, always been made by our tools, the shape of our values. The tools I've shown you today are going to give us infinite expressibility. So the real question is, what values do we want to see expressed in our world? And for me, I think we need to be thinking about values like going from constructing things to growing things, from fabricating things to farming things, shifting our focus from craving obedience from our tools to valuing and increasing their autonomy. We're going to move away from extraction and embrace aggregation. We'll shift from creating things that are disconnected and isolated to creating things that are inherently connected and related. And we will leave behind strict rigidity and encourage fluidity. So these are the values, the qualities that I believe we need to instill in our tools if we expect them to become our true creative partners in shaping our future. And that's why when I think about the future, I think I know what it's going to look like. The shape of things to come will in fact be an expression of our values, an expression of our imaginations, and an expression of our humanity. I believe that the shape of things to come looks a lot like who we are. Thank you.